This is Geology 100 Natural Disasters. My name is Dr. Scott Nowicki, and today's topic is volcanoes. If you were to slice the Earth open, one would think that if you went down deep enough, you would run into magma. Turns out that is actually rarely the case. More importantly, the mantle, which is the layer of the Earth that goes between the outer core and the crust itself, the mantle tends to be solid, or at least semi-solid, and it flows over time. So this idea of a liquid interior of the Earth really doesn't apply until you get down to the outer core. That, of course, is entirely iron and nickel, and it is liquid. But the mantle itself is effectively flowing in a very slow, sticky way, so that the heat that comes from the outer core works its way up into the mantle, heating up that semi-solid material. It rises until it hits the bottom of the crust, then it comes back down. So our idea of volcanoes is tapping into the source. It's not really the case. It is this heat as it rises and gets closer and closer to the crust is more likely to melt mantle material. As this plume of material works its way towards the bottom of the crust, it's more likely to melt and become a liquid. When that magma reaches its way to the surface, it becomes lava. And at that point, we have volcanoes. So we're going to talk all about the surface processes that occur in volcanism, but the reality is this entire thing is driven by plate tectonics. There are two main volcanic styles that we're going to talk about. First of all, it's the effusive volcanic eruptions. Effusive means the flows are very fluid. They are typically of mafic composition. By mafic, we mean dark colored, mostly composed of iron and magnesium silicate. They are a number of different types of flows, including aa and pahoehoe, and if you add gases in there, you can have some pretty interesting volcanic features. But they tend to form these shield volcanoes and cinder cones, whereas the other style of eruption is explosive. This means they are very viscous flows. They are often of felsic composition, so this is rhyolite. Unlike the dark-colored basalt, rhyolite is lighter in color and composed of more silicate-rich melts. These tend to generate light-colored volcanic rocks, tend to generate a lot of ash and these pyroclastic materials, and often the type of volcano that forms is a stratovolcano, but there are various types of flows that will actually occur within stratovolcanoes. The mafic lava, often basaltic composition lava, is very effusive, produces very fluid flows, and it tends to form smooth flows and shield volcanoes, sometimes with cinder cones. And so here is an example of a cinder cone that is just north of Flagstaff, Arizona. The cinder cone is actually called SP Crater. It is a steep-walled pile of cinders that was generated from a very volatile-rich eruption. But then once the gas ran out, this effusive flow breached the bottom of the cinder cone and proceeded to flow out over the surface. Intermediate to felsic volcanoes produce these more sticky flows and tend to form steep-walled stratovolcanoes and lava domes like we see at Mount St. Helens. Here's a picture of Mount St. Helens. I took this picture back when the volcano was still erupting. The lava dome was erupting and slowly growing over the course of days. You could see the gases come off the lava dome. But for the most part, the entire structure is called a stratovolcano. Given these two large-scale compositional and eruptive differences, we can start to focus in on the details within these different types of flows. This basalt, this mafic effusive lava, can often produce these what are called aa flows. And as you can see from the picture, they're not necessarily all that hazardous because they're relatively slow-moving flows. These aa flows produce this really rough surface, and as the flow works its way across the surface, it will move in a very lumbering type fashion, so that as each new piece cools on the surface and breaks off, new lava will push in from underneath it. But it tends to move relatively slowly and be really clinkery. Basalt can also flow in a more fluid fashion. These produce the pahoehoe flows. This is a very liquid, very runny lava that is composed of the same materials and produces this nice black basaltic rock, but it can move relatively smoothly. And it can produce either these bulges and tongues of lava, or it can produce these ropey type textures. And pahoehoe specifically is this ropey type texture. All of these types of flows, pahoehoe, are all basaltic. They are effectively what we consider to be effusive. On the other hand, there are drastically different types of flows that occur with these felsic to intermediate compositions. These include pyroclastic flows, pyroclastic surges, and of course pyroclastic materials. Pyro means fire, and clastic is pieces. These explosively emplaced materials can be particle sized to bomb sized, are often felsic in composition, gas driven explosive eruptions that are probably the most hazardous type of lava flow that there is. And we have a video of mountains erupting in Japan in a very catastrophic pyroclastic flow.
Something triggers a pyroclastic flow about 10 times bigger than all that came before. Within moments, it overwhelms the valley. By the time a TV camera in the village records this scene, Maurice, Katya, and 41 others are dead.
So as you can see from that eruption, these are very violent, very high-speed flows, and a lot of gas is driving this eruption. With that in mind, there are three main factors that control the types of eruptions that occur in volcanoes. First is viscosity. Viscosity is simply resistance to flow. It is dominated by the composition. The more mafic a magma is, the more effusive the eruption is likely to be, and the more felsic the magma is, the more explosive the eruption will be, and is of course dominated by the geologic environment. There are only certain tectonic environments in which these high viscosity volcanoes are likely to occur. The second is the volatile content, and that is the amount of dissolved gas and water that is within the magma itself. The more volatiles there are, the more likely that the eruption will be explosive. And then finally, of course, is the volume. That's how much magma you start out with and how much eruptive material comes out. If it's only a small amount of magma, it tends to make very small volcanoes, very small flows. If there is a lot more magma, it is more likely to generate these big caldera type eruptions rather than a small cinder cone or flow. The best way to visualize what's going on here is to use the Volcano Explorer. I've provided the link below. This is a fantastic online tool that will allow you to generate your own volcano and modify at least two of these controls, the viscosity and the volatile content. I will let you do that on your own as part of an assignment, but this is something that you should spend a decent amount of time interacting with. These three factors that control the type of flow and the type of eruption produce these drastic different types of volcanoes. So here's our list of 6 volcanoes: flood basalts or plateau basalts, shield volcanoes, cinder cones, composite or stratovolcanoes, volcanic domes, and calderas are all the common types of volcanoes that we can see around the planet. The violence and the viscosity of the flow increases as you work your way down. So the least violent type of flow are these basalt flows that occur from these fractures and fissures that open up from the ground and lava just pours out. The second would be a shield volcano. You can start to have cinder cones that form on shield volcanoes. By the time you get down to composite or stratovolcanoes, you get sometimes fluid flows, but oftentimes more of these stickier or pyroclastically emplaced layers. Volcanic domes are actually not very violent. They are slowly flowing, but they can often catastrophically fail and produce a pyroclastic flow. And then finally, there are these calderas. They are absolutely massive. A caldera is actually a collapse feature on the surface that occurs when a magma chamber at depth empties out its material. Using the virtual volcano or the Volcano Explorer, you can generate a shield volcano, a cinder cone, a stratovolcano, and a volcanic dome. You can see how each of these different types of flows are generated simply by modifying the composition and the volatility. A shield volcano is a classic Hawaiian style volcano. They don't have to occur only in Hawaii. There are shield volcanoes that occur in the continental United States that occur around the planet. But Hawaii is this classic example because it tends to be a vent or a series of fractures that allow this magma to rise up, but because it moves so fluidly, it's able to form these massively tall mountains, but they have very gently sloping sides. As opposed to cinder cones, which can actually often occur within shield volcanoes. A cinder cone is a loose pile of cinders that is generated most likely from a fire fountain, from when there are gases within the magma, and as it blasts out these pieces, they're flying through the air and cooling to fall on the ground as cinders. And we have a video from an Icelandic volcano erupting, showing just how fantastic these things can be.